Okay, so I'm looking now at number 12, where it says let p of x be blah, 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 and it says find p of minus 1. Before we solve it, let me very quickly remind you of something which I think we've learned, but maybe you've forgotten. So here I have a graphing calculator, and what I want to show you is that if you have any quadratic of the form ax squared plus bx plus c, so for example 4x squared plus, I don't know, or let's say minus any number, 3x, okay, plus 2, or let's say minus 3, say minus 3. This minus 3 here gives us one of the points on the function. This intercept here, 0 comma minus 3. So that minus 3 is going to be the what? The y-intercept. So if I didn't show you this stuff here, if I just covered that, I told you, oh, here's some graph, and I know that it crosses the y-intercept at minus 3, then immediately you should know that the graph or the function ends in minus 3. So this final value here, this c term, will give you the y-intercept. Let's try another one. Actually, I'll hide this, and I would type it. I would type it while not looking. So I'll say y is equal to, and then let's see. Let's just say minus x squared plus 5x, and then I will hide this from your screen and type something. I'll type, let's say, okay, so based on what you just saw, so here we see that this thing intersects at 0 comma 3. You should know exactly what I just typed. What did I just type? I typed plus 3. So the final term here gives you the y-intercept. Okay, so 0, 3 tells you that this is plus 3. Okay, so now that that is covered, let's get back to this. So this question looks a bit confusing, but one thing you could do to simplify it is to, instead of saying p of x, think of this as f of x, because you're more familiar with that. So let's do f of x here is a quadratic polynomial. And if it's a quadratic polynomial, it must look like this. fx is equal to ax squared plus bx plus c. So our task is going to be to figure out this stuff, to figure out the a, the b, and the c. Okay? And we know here that p of 0 is minus 1. So we can think of that as f of 0 is minus 1. F of 1 is 9. And f of 2 is 25. Okay? And hopefully now you remember that whenever you see f, then you're thinking of y's, right? Whenever you have like f of x of something, then you can think of that as y is equal to that thing. Right? So here we have f of 0 is equal to minus 1. We can think of that as y is equal to minus 1. And what is x? X is the thing that goes into the parentheses, right? Hopefully you remember that. Okay, so what this basically means is we've been giving a set of x and y values. And we can plot those values, or at least we can put them in a table. So let's put them in a table. So we're going to put in our x's and our y's. Let's erase some of that. And let's use a different color. So the first x is what? 0. So 0 goes in here, 0. And what comes out? So it says f of 0 is minus 1. That's the same thing as y equals minus 1. So our first y is minus 1. And this one, we have what? 1 goes in. And what comes out? 9 comes out. Then here 2 goes in. That's our x. And what comes out? 25. So that's our y. Perfect. So now we have 3 points. And if you remember what I just said, if we know that this graph here cuts the y-axis, intersects the y-axis at the point 0 comma minus 1, 0 minus 1. Let's imagine the graph looks, I don't know what the graph looks like. Let's imagine it looks like that. Okay. Then basically we know that this graph, which is represented by this function, or this function, which is represented by this graph, must have its final term be this thing here, this minus 1. So this c gives us the y-intercept. Hopefully you recall that from the Desmos I just showed you. Okay, so basically then we can rewrite this thing. We can rewrite it as, y is equal to ax squared plus bx minus 1. So we found c. So we're almost done. Now we just need to find a and b, and then we'll be done. Okay, so to find a and b, let's get started with that. To do that, all we're going to do now is plug in these points into this stuff here for y and x, and we get a system of equations. What does that mean? Let's try it. So I'm going to rewrite this up here at the top. I'm going to write y is equal to ax squared plus bx minus 1. Okay, and since we've already used this pair, let's ignore that pair and look at the other two pairs of values. So here it says when x is 1, y is 9. So we can plug y in there and plug x in for the two x's. So let's do that. So here we have 9 is equal to, a is just a, x is what? 1. So we have a 1 squared plus b is just b, x is what? 1 times 1 minus 1. And that gives us what? That gives us 9 is equal to a times 1 squared, that's just 1a, or just a, and b times 1, that's just b, minus 1. And then we can add 1 to both sides, and that will cross this out, and we get 10 on the left-hand side. So let's just do that so we don't have too many steps on our paper. That gives us 10 is equal to a plus b. Okay? And we do the next one. So here our y is what? 25. So we're going to have 25 is equal to, we use a again, a, and then x is what? 2. So 2 squared plus b, 2 minus 1. And that'll give us 25 is equal to, what's 2 squared? 2 squared is 4. So 4a plus 2b minus 1. And we can add 1 to both sides again, and we get 26 here. Let me do that neater. We get 26 on the left, and we get nothing here on the right. So 26 there. Okay, and now we have a system of equations, right? We can almost solve it. What should we do first? Maybe we multiply this one by 2, so we can have 2b, and we can subtract. All right, let's try that. So we're going to multiply this whole thing by 2. And where should I put it? Let's see. Let's make some space. Put that up a bit. And I will rewrite that now in a different color, maybe orange or red, as 20 is equal to 2a plus 2b. Okay, so let's call this thing here, that was our equation 1, and we just changed it now to get our equation 2, and this is our equation 3. But you don't really have to write this. So what are we going to do now? We're going to subtract 2 from 3, and that'll give us a nice thing that we can solve. So we do 26 minus 20, right? And that'll give us 6 is equal to 4a minus 2a, that's just 2a, and 2b minus 2b is just 0. So we get 6 equals to 2a, and you can go on from there, right? So a is equal to 3. So we've solved for a, and now we can plug in a into this guy. So we know this must be 3. What's left to find b? How do we find b? Surely you can find b. If we know a, we can plug a into any of these 3 equations, and we get b out of it to solve there for b. So I'll let you do that, and I'll also include another question of a similar kind for you to practice this concept. Okay, let me know if that's still not clear, and I will maybe record another one. Okay, good luck.